All right, the way that we write numbers in our systems is interesting because with only 10 digits, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we are able to write whole numbers as large as we would like. This is because what we really are doing is counting how many powers of 10 that we have. So write each of the following numbers as a sum of multiples of powers of 10. The first is done as an example. So 274 is 200 plus 70 plus 4. Well, 200 is 2 times 100. 70 is 7 times 10, and then plus 3. So it's 2 times 10 to the second plus 6 times 10 plus 3. The next one is 3,000 plus 800 plus 40 plus 2. Well, 3,000 is 3 times 10 to the third. 800 is 8 times 10 squared. 40 is 4 times 10, and then plus 2. Next one, 5,000 plus 80 plus 1. So 5 times 10 cubed plus 8 times 10 plus 1. And finally, 20,000 plus 1,000 plus 400 plus 70 plus 8. So that's 2 times 10 to the fourth plus 1 times 10 to the third plus 4 times 10 squared plus 7 times 10 plus 8. We can now use algebra to replace the base of 10 with the generic base of x, or whatever variable you like. So let's look at 63,735. As in number 1, write this number as a sum of multiples of powers of 10. So 60,000 is 6 times 10 to the fourth power. 3,000 is 3. That was a terrible 3. 3 times 10 to the third power plus 700 is 7 times 10 squared. 30 is 3 times 10 and 5. So if x equals 10, write this number in terms of an equivalent expressing involving x. So it's 6 times x to the fourth plus 3 times x to the third plus 7 times x squared plus 3x plus 5. So all we did is we took the tens and replaced them with x's. The base of a polynomial certainly doesn't have to be 10, but all polynomials have a form similar to your answer in letter B. Let's define them a little more definitively. Any expression of the form ax to the n power plus bx to the n minus 1 plus and so on, where the exponents are n minus 1, n minus 2, etc., are all positive integers. Note that not all powers need to be present because the coefficients of a, b, c, etc. can be 0. Of the expressions shown below, circle all of them that represent polynomials. Discuss why the ones that aren't polynomials fail the definition above. Well, we know that this one is a polynomial, and so is this one, because it has x to the second, x to the first, and the other one is x squared, x to the third, and x to the first. But I'm looking at this one right here. It is not a polynomial because x in the denominator indicates x to the negative power, and remember it has to be positive integers. And then looking at the other one, the power must be constant. So the x's are in the exponents. So x are exponents, which is not what we are working with. It is often important to place polynomials in their standard form. The standard form of a polynomial is simply writing it as an equivalent expression where the powers are always descending, so it goes from the highest power to the lowest power. So we're going to put these in standard form. So a needs to go 5x to the third first, then 3x to the second, then negative 8x to the first, and then 7. Letter B, 9x to the fourth is correct going first, but then it should be negative x squared plus 2x plus 1. And finally, it should be negative 5x squared minus 2x plus 3. Polynomials are simply abstract representations of numbers that we see every day. So look at number 5. Consider the numbers 523 and 271. So we're going to do like we did in the beginning. We're going to take 523 and it's going to become 5 times 10 squared plus 2 times 10 plus 3. And 271 is going to be 2 times 10 squared plus 7 times 10 plus 1. Add these powers by adding each individual power of 10. So what that looks like is we're going to add together the ones that are 10 squared. So I have 5. So I have 5 10 squared and 2 times 10 squared, which becomes 7 times 10 squared. And then I have 2 times 10 and 7 times 10, so those have the same. So those become 9 times 10. And finally, 3 plus 1 becomes 4. If I were to add together 523 and 271, I get 497. Is it true that I get 497? Yes. So use this idea to add for letter C. Well, we're going to combine the like terms. So 5x squared and 2x squared is 7x squared. They are like terms. 2 and 7x become 9x, and 3 and 1 become 4. But now we're going to look at the next one. I have negative 4x squared and positive 7x squared. Those combine to make positive 3x squared. Positive 9x and negative 5x combine to make positive 4x. And negative 3 and positive 4 combine to make 1. So all we did is we combined like terms. Finding sums of polynomials is fairly easy. Subtracting them, though, can lead to a lot of errors. So find each of the following differences. Be careful and rewrite as an equivalent addition problem if necessary. So if we're looking at letter A, it says that you are subtracting the second polynomial, which is 2x squared minus 4x plus 7. So really what you're doing is this negative is really, there should be a parenthesis there to show that you're distributing that negative. So what it is it's a negative 2x, then it becomes a positive 4x, and a negative 7. You distribute that negative to all three of the terms. So now 6x squared minus 2x squared is 4x squared. 5x plus 4x is 9x. And 3x minus 7x is negative 4. It's a little bit easier to see when it's written out not vertically but instead horizontally because you are distributing that negative. So it becomes 4x squared minus 2x plus 7. And if we distribute that negative, a negative times a negative is a positive 2x squared. A negative times a positive is a negative 1x. And a negative times a negative is a positive 3. So this becomes 6x squared minus 3x plus 10. For each of the following, write an equivalent polynomial in simplest standard form. So it's asking you to combine like terms and then put them in descending order. So we find all of our x squareds. 6x squared minus 1x squared is 5x squared. Positive 2x, positive 4x becomes positive 6x. Negative 3, negative 1 becomes negative 4. You will see that you have this negative that needs to be distributed. So I'm going to rewrite that as negative x squared, negative 4x, positive 1. So I have positive 6x squared and negative 1x squared becomes 5x squared. Positive 2x, negative 4x becomes negative 2x, and negative 3 and positive 1 becomes negative 2.